Hi guys, in this video I'm going to show you how to solve inequalities. These are the inequalities that you learned in elementary and middle school. Greater than, less than or equal to, greater than or equal to. When we graph these inequalities, if we have equal to, we always fill the circle on the number line to represent the equal sign. When we don't have equal to attached to the inequality, that means we leave the circle open on the number line. Let's take a look at some examples. So when we talk about solutions for inequalities, we have a solution set instead of just one value, like equations. So when we have a solution that is represented by x is greater or equal to 5, that means I'm including every single number greater than 5, and it can be 5 as well. So to represent this solution set on the number line, I'm going to have to place 5 here in the middle. I have greater than or equal to, so that means I'm going to make an a closed circle to represent the equal sign. And then since I'm including every single number greater than 5, I'm going to have to shade to the right of the circle. Now, in the second inequality, we have x less than or equal to -3. Again, this is a solution set. That means I'm going to have to represent the solution by graphing -3 here in the middle of the number line. I'm including -3 in the solution set. So the solution set includes a -3, but it also includes every single number less than -3. That's why I'm going to shade to the left side of the circle. We have x is less than -20. Again, in this solution set, we have -20, but -20 is not included in the solution set. That's why I'm going to make an open circle. I'm including every single number less than -20. That's why I'm going to shade to the left. Next example, we have x is greater than 1/2. So again, 1/2, going to represent 1/2 here in the middle. 1/2 is not included in the solution set. That's why I'm going to have an open circle. But the solution set includes every single number greater than 1/2. That's why I'm going to shade to the right. We solve inequalities the same way we solve equations. We use the different properties of real numbers to be able to justify our work. We use the distributive, the associative, and the commutative properties. We also learned about the properties of equality last time when we solved equations, and today we're going to learn the properties of inequalities that can help us solve inequalities. So the properties of inequalities are similar to the properties of equations. We have the additive property of inequality, which means we can add or subtract the same quantity from both sides of the equation. And we have the multiplicative property of inequality, which means that we have to, if we multiply or divide the same quantity from one side, we have to do it to the other side as well. The only difference is that when we multiply or divide by a negative number, the sign of that inequality has to flip to make a true statement. So every time we multiply or we divide by a negative number, just like this example, the equality sign flipped. Again, here we are dividing by a negative number. That's why the inequality sign flipped to make a true statement. So what is exactly the difference between solving equations and inequalities? We use the property of inequalities when we solve inequalities, which means we're going to have to remember to flip the sign of the inequality when we multiply or divide by a negative number. And the solution for the equation is one number or two solutions at the most, while the solution for the inequalities may include multiple or infinite solutions. Let's take a look at this example. We have negative 4 times x minus 2 less than or equal to 4. We said that we solve inequalities almost the same way we solve equations. That means we're going to have to start with the distributive property, which means we're going to distribute negative 4 into the parentheses. So I'm going to end up with negative 4 times x, which is negative 4x, negative 4 times negative 2, which is 8. Now we have a two-step inequality. My next step is to use the additive property of inequality to take away 8 from both sides of the inequality. So that means I'm going to end up with negative 4x less than or equal to negative 4. And this is a one-step inequality. All I need to do now is to use the multiplicative property of inequality by dividing both sides by negative 4. Now remember, we said that at this point, there is a difference between solving equations and solving inequalities when we divide or multiply by a negative number. When we multiply or divide by a negative number, we need to flip the sign of the inequality. So instead of less than or equal to, now we have greater than or equal to. And the final answer is x is greater than or equal to 1. Now, to graph this solution, we don't have just one number as a solution. We don't have two values as a solution. We have many values. And to represent the solution set on the number line, I'm going to have 1 here in the middle of the number line. And the inequality says that we need to include every single number equal to 1. That's why I have a closed circle. And every single number greater than 1. So that's why I'm going to have to shade to the right of the circle. And this is how I represent the solution set. The solution set is infinite numbers. It's every single number equal to or greater than 1.